Hello everyone, by the way I'm Ronald T. Saladaga, and today I'll show you an Excel program about the design of actually loaded ties, tied and spiral column. So before we start having an example, by the way I am using NSCP code 2010 and 2015. So let's start and see if this program is working or not. So let's have an example. Let's try this situation 1. So design a square and spiral tied column to support an axial dead load of 1500 kN and an axial live load of 2500 kN. So use FC prime of 21 MPa, Fy of 415 MPa for vertical bars, and an Fy of 276 MPa for spirals. So let's input all the values. Dead load of 1500, live load of 2500, FC prime of 21, vertical for bars for 15, 275, 276 rather, 276, still ratio of, let's say still ratio of 0.02, assume still ratio if not given, then assume the value of your main bars, let's say we have 32, and if our main bar is less than or equal to 32, our ties and spiral must be 10 mm. And steel covering for our spiral, let's say we have 40 mm. And so for tied column, we have ultimate load of 5800 kilonewton. We have area gross of 432,437 millimeters squared, and the x value here is your width or the height of your column, which is 657.6, and because you're the one designing, you must be the one to decide the value of your dimension. So let's say we have 658 mm, and so we will get value of our steel, area of our steel, which is 8659.3 millimeters squared, and so the number of our steel bars are 10.772, or let's say we have 11 bars, and so our maximum spacing will be the least of these three, 512, 480, and 658. So the smallest value is 480, so let's input the value for 80 here. And so we will see here for tied columns, we have a cross section of 658 millimeter by 658 millimeter, main bars of 11 of 32 mm diameter bars, and the ties of 10 millimeter diameter lateral ties spaced at 480 millimeters on center. So we're done in the tied column, so let's go for the spiral column. We have ultimate load again of 5800. We have area gross of 352,733 millimeters squared, and the D here is the diameter of your pillar or your column, which is 670.33, and let's say you design it for about 675, and so you will get an area of your steel bars of 7,153.3 millimeters squared, and the number of bars of 8.89. So let's say we have number of bars of 9, and so we will get the AC of 277,910. This is in millimeters squared, and we have phase mean of 0.0098, and so we will have a value of our S, or our spacing, which is 52.804 millimeters on center. Let's say we have a value of 52 millimeter on center, so our S clear will be 42 millimeter. And so for spiral column, we have a cross section of 675 millimeter diameter, main bar of 9 of 32 millimeter diameter bars, and our spiral of 10 millimeter diameter spiral space at 52 mm on center. And I think that's all. Thank you for watching.